Hello, and welcome to yet another check-in session for our Kubestronaut cohort. My name is Mumshad, and I'll be hosting this session. So I do see a few of you who have joined the chat. So if you're here, do share a hi in the chat. I see Nestor. Hey, Nestor. Long time. Pegel, we have hey Pegel, welcome to the session. We have Aviroop, we have Alan Najman, welcome Alan. Alon, we have Amit Shil. Thanks for joining, Amit. We have Christian Cortez from Ireland. Hello, Christian. We have Ashish Sahu. Hi, Ashish. We have Dare Okoshil. Hello. We have Dick Bahadur Katwal. We have Shobit Nigam. Hello, Shobit. Alum Najman. Yep, I already said. We have Divyansh Tripathi. We have Ramesh, who's joining in us from LinkedIn. So we're live both on YouTube and LinkedIn, in case you didn't know. We have Muhammad Omar from San Jose. Welcome, Muhammad. We have Shubham. Thanks for joining us, Shubham. Good to see you here. We have Sudhakar. And Muhammad Zaidan, who's also joining in from LinkedIn. Welcome. We have Neeraj Vasudeva from Austin, Texas. So do keep saying your highs in the chat. So this is check-in number 9, check-in session 9. Let me quickly share my screen and we can get started. All right, here we go. So this is check-in session 9. I want to start by congratulating those who have, in the past 2 weeks since our last check-in, completed their certifications. So just to begin with, we have Hariharan, who's a DevOps engineer at Nokia, who's completed his CKA certification. So congratulations to Hariharan. We have Samit Prabhudita, who's also completed the CKA. So congratulations, Samit. We have Shubham Gawaz, who's also completed the CKA. So congratulations to Shubham. We have Tapiwa Munetsi, who's also completed the CKA. So congratulations, Tapiwa. We have Kronal Patel, who's completed the CKA as well. So congratulations to Kronal. Navdeep Singh Rathod, who's an automation architect, also completed he's done the KCNA, and pending CKA, CKAD, KCSA, and CKS. So awesome stuff, Navdeep. All the best to all the future certifications, and congratulations on this one. We have Dylan Da Costa, who's completed the trio, the CKAD, CKA, and CKS. So congratulations to Dylan. We have, by the way, we have another important announcement. So we've had probably the youngest Kubestronaut. So this is Muhammad Awabur Rahman, who's only 16 years old, and he's completed his Kubernetes certification journey. He's done all the 5 certifications and is officially a Kubestronaut. So a big shout out to the wonderful achievement at such a young age. So congratulations. All right. So I also want to call out those who have completed some of the other certifications. So we have Riduvarshini, who works as an associate software engineer at Tech Mahindra, who's completed the HashiCorp Vault Associate certification. So congratulations to Riduvarshini on completing the certification. We have Nitin Jagwani, who's completed the Prometheus Certified Associate certification. So congratulations to Nitin. We have Mahesh Prabhu, who's completed the Terraform Associate certification. So congratulations to Mahesh. We have Artem Lachko, who's a platform engineer and ambassador, who's completed the Prometheus Certified Associate as well, the PCA certifications. So congratulations to Artem. And we have Niamul Kabir, who's also completed the HashiCorp Terraform Associate exam. So congratulations to Niamul. We have Muhammad Mahmoudi, who works was an architect solutions at Sopra Steria, who's completed the Terraform certification as well. And we have Sagar Otekar, who's a Docker Captain Kubestronaut. He's done his RSCSA. So congratulations to Sagar for that achievement. So a quick announcement, a bunch of new and recently released courses, as well as some of the upcoming courses on KodeKloud. We had released in the past the fundamentals of MLOps course. We have a Kubernetes auto-scaling course, a course specifically designed for Kubernetes auto-scaling. And we have a bunch of AI courses as well. So the AI-assisted development, running local LLMs with Olama, the AWS SageMaker. And then we also had the Certified Backstage Associate, the CBA exam by Sanjeev. So we're working on a bunch of courses to help you complete the Golden Kubestronaut track, which was one thing that was announced in the London KubeCon. And we also have, some of the courses that are going to come out supporting that are the Istio Certified Associate, Cilium, as well as the others that are pending in the Golden Kubestronaut track. We also have Migrating Jenkins Pipelines to GitHub Actions course that's going to come out very soon. We have the Event Streaming with Kafka course that's going to come out very soon, and the AWS SageMaker. So these are some of the new courses that are going to come out. There's a link here where you can go and see some of the latest courses, as well as the courses that are upcoming on KodeKloud. All right, we have made some updates to both the courses, the CKA and CKS. The CKA especially, just want to call out some of the high-level items here. So last week we added a lecture and lab on priority classes. This is now available for you in the CKA course itself. I'm going to show that in a minute, and that's what we will look at throughout the rest of this lecture or this session. Keep saying lecture, sorry, habit. And then we have updated, we've also updated the etcd cuddle and etcd UTL article. We have made some updates to the etcd backup and restore lab, and we've removed the advanced etcd lab as well as the related solution video. So we had two labs on etcd. One was the backup and restore. The other was an advanced lab. It was a bit more tougher, but we don't think that's any longer needed as part of the certification preparation. So we've removed that and added a bunch of other new labs for Flannel, Calico, and other things. We've also removed some of the old references to Weave-based solutions. So we had used Weave in some of our videos as well as labs. So all those labs are now removed, and we've added new lab scenarios using Flannel and Calico-based networking solutions. And then we have also added, there was a missing lab on CRD. There was a lecture, but there was no lab. So we've added that lab as well. On the CKS course, we've added the P2P encryption with Istio lab. So that's an additional lab that's added. to help work with the Istio-related part of the CKS course. We have a separate course that's coming out for Istio, as I mentioned in the previous slide. This is an Istio certification course that's going to come out this right here. And that will cover these as well as a lot more other labs and scenarios that are needed for Istio. So Istio is also one of the tougher certifications from CNCF, similar to the CKS. So our goal is to make that all easy for you. So we're gonna be working on, we are working on a number of courses with a lot of labs and hands-on practices to help you there. All right. By the way, if you have any questions, feel free to add them to the chat. And as when I go through and take a break, I'm gonna look through the questions and help answer them. All right. So we have two cohorts. The first cohort was we started in January. Our goal is to get certified in all of the Kubernetes certifications by the end. And then we had a second path to it, which started with KCNA, CKAD, CKA, CKS, and KCSA. Of course, it's just a recommendation. You're free to, depending on your current skill level, your pace, you're free to modify this on your own. We have a leaderboard at leaderboard.KodeKloud.com. Let's take a quick look at where things are as of now. So in the January cohort, we had 871 plus that were enrolled. And if you take a look at it, so we already have 170 who've become Kubestronauts. And out of for the CKA, we had about 500 who were attempting or who joined the cohort. We already have about 129 that have completed the certification. So you were supposed to complete the certification by end of the first quarter. I know it may be lagging a bit, but do put in time to go through and complete the certification. Similarly, for CKAD, we had about 258 people who had started the CKAD course. So that's what you should be looking at right now, because those who are part of the January cohort, by the end of April, you should have completed the CKAD. Now I can understand, life gets in the way. So if you are if you have not started the attempt yet, please do give it a shot and aim to complete it. And then we'll have the KCNA, which is planned to be achieved by the end of May. So you have a month. So those of you who have already completed the CKAD, please proceed to going through the KCNA. So if you've already done CKA and CKAD, KCNA shouldn't be that hard. You already have the hands-on experience, so you should be able to just go through it and complete that. And once you're done with that, from August, you then have 2 to 3 months to get the CKS completed. So that, as we all know, is one of the tougher exams. All right. So if you go back, if you still have, if you have not joined the cohort yet, do join now. So go to leaderboard.KodeKloud.com and select the April cohort, and then you'll be able to find the join cohort button. Click on that, and then you can be part of the cohort. So far we have about a total of 570 plus that are enrolled in the cohort, distributed between different courses, and a lot of them have already completed the certification. So there are 61 of them have already completed the certification. So this is the new cohort. We're starting with CKA right now, and hopefully by the end of June is when we're supposed to complete the CKA. All right, so and we'll close the applications to the April cohort maybe in a few days from now. So if you haven't done that already, do jump in and join the cohort. All right. So cohort 2 starts in April and ends sometime in March, ideally by December, end of the year, but we have a buffer time, a couple of months. If you have retakes or anything, then we have time till the end of March. All right. Similarly, for cohort 2 too, we have the other path, which I would call as the easier path. Starts with KCNA and then goes to CKAD, CK, and others. So yeah, I just spoke about the milestones. So I'm just gonna skip through that. But yeah, if you're a part of cohort 2, by 15th of May, you're expected to complete the 5th and 6th modules, so cluster maintenance and security by then. And then by the end of May, you're supposed to complete the security and storage sections of the CKA course. That will take you to about 65% completion. And if you're part of path 2, KCNA, then by the end of May, the goal is to get KCNA certified. So by next week, you should have done modules 5, 6, and 7, so service mesh, storage, and cloud native architecture sections. All right, so if you're new to this, know that we have these check-in sessions. We have a private Discord channel for those who are participating in the cohort. You can share your challenges with each other, get help from each other. You can share your wins and celebrate your achievements, and then set new milestones. So definitely join the Discord channel. We'll share the link here in the chat. And if you join the cohort, you'll also see that we have this email course. So you'll get emails with snippets of whatever you learned. And we have already started getting some really good feedback on the emails. So these are just some screenshots from the feedback that we've been getting. So do check your emails for that short but crisp information that you'll get once you join the cohort. All right, and as always, aim to hit your milestones no matter what. Don't be a perfectionist. If you feel like 80% confident for the exam, I would say just go ahead and try for the first attempt. And when you lock in on that first attempt, when you book the exam, that kind of puts you in this mode of really going for its hack to get you to push yourself to complete it. And then if you get stuck in I know the Kubernetes courses, especially the CKA and the CKS, covers a lot of topics that may not be very familiar to you, or an area that you probably are not very comfortable with. So don't get stuck in those areas. Just skip them. For now, go ahead and complete the rest of the course. And then when you come back and look at it, you would have gained a lot more connected knowledge that would then help you get back and learn that in a better way. So and if you feel like you can cover more in a shorter period of time, go for it. If you want to take a weekend out to just make some real progress, absolutely do so. So learn at your own pace. And of course, every time you make progress, you have some small wins, you complete a certification, share it in the Discord channel, and you get a lot of support from the others. All right, so if you haven't booked your exams, we have an exclusive 30% off coupon code from Linux Foundation. So use 30 code with a K, and you get a 30% discount for your bundles. All right, so let's get into the topic of discussion for today. And if you have any questions, feel free to drop them in the chat. All right, so today I thought what we could do is pick one of the topics that was recently added to the course and just go over that. And we'll walk through the lectures, the lesson, the theory, and then after that I'll open up the lab and we can go through the lab as well. And one of the things we could do this time around is that you could help me walk through the labs, right? So if you could, once I go through the session, you could help me answer the labs. You could give me the options, the commands, and help me go through the lab, right? So just checking the chat for any messages. So there's some questions about why start with the CKA instead of starting with KCNA. So there are two paths, as I mentioned. The path one is what I call, for those who are a little bit experienced, I would recommend starting with the CKA, because you cover a lot by going through the CKA. You gain a lot of hands-on experience, and that kind of makes all the other exams easier. So if you are confident and if you are a little bit, if you have that enough hands-on experience, then I would highly recommend starting with the CKA. If you're not, if you want to start with, if you don't want to take that much of a risk, if you want to start with a smaller course, or one that is not hands-on, then you can go for the KCNA, which is not a hands-on exam. The cohort, we start the cohorts every quarter, so we don't have a May quarter, but it's still May, and you can still join the April cohort. You probably would be a little bit late compared to the others, but you can catch up. It's a year-long cohort, so no problems there. All right. All right, so I think we can get started. I'm not sure if you can see my screen, so I'm going to try that again. All right. Cool. So the topic for today is priority classes. This is something that we newly added to the course just a couple of days back, and is one of the topics that fall into the scheduling section of the course, right? So if you go to the CKA course, and you have these different sections, and you have this section called scheduling, and within that you have a bunch of different lectures. So you have the manual scheduling, you have information about what the scheduler is and how scheduling works in general. You have information about like daemon sets, and one of the topics that we've recently added to that section is priorities and priority classes. So what are priority classes, or why do we need priority classes, right? So we know that in Kubernetes, there are different workloads that run in the cluster. So we know that there are apps that we host on Kubernetes, but more than that, we have the Kubernetes components itself that run as services, as pods on a Kubernetes cluster. So the Kube API server, the controllers, all of them that are needed to run Kubernetes itself also run as pods, also run as ultimately as containers on the cluster itself. So you have the Kubernetes components, and then you have, let's say, different types of workloads. So you have stateful workloads, like you have databases, you have critical applications that are running, and then you have probably lower priority tasks as well, like jobs, background jobs or scheduled jobs that only need to run maybe once a day. It doesn't really matter when it can run. It just needs to run at a time when there is really no heavy load or things like that. So there are different workloads that run on a Kubernetes cluster with different priorities. Now, as you can imagine, the cluster is only is as good as hosting the applications on it. So the applications running on Kubernetes cluster are only as good to run if the Kubernetes components themselves are healthy, right? So if the API server or the controller manager goes down, is going to eventually impact the applications running on the cluster. So we know that those should always have higher priority. We don't want the API server itself or any Kubernetes components to ever be impacted by any kind of workload on the cluster. And then we have, as I mentioned, databases. If databases are there on the cluster, then probably those would always have higher priority. We never want the databases to be impacted by any kind of resource constraints. And then, of course, we have the critical applications. So those are the kind of the priorities that we have. And there's a way to define priorities in Kubernetes using a number, right? So you could say something has a priority of 1 billion, and then that would be higher priority, and it can go all the way down to 0 to then negative numbers, and then all the way to minus 2 billion or so, and that's the lowest priority. So we can define priorities based with some of these numbers, right? There's a range that you can use to define priorities, and this particular range of, say, negative 2 billion to positive 1 billion, that's for the apps, what we call as the app space, right? So these are the applications that we run, that the end users run on a Kubernetes cluster. But apart from that, there is this special set of another billion or so priority range that's defined, and that's specifically for the Kubernetes component itself. So we know that the system components or the Kubernetes own components are the most critical, so we want them to be the highest, having the highest priority. So this is how the priorities are and the ranges are defined. So let's understand how to view priorities, right? So if you run the kubectl get priority class command, then you get a list of the different priority classes that are created. So by default, there are 2 priority classes that already exist in any Kubernetes cluster. So you have the system cluster critical priority class, and then you have the system node critical priority class. And as you can see, each of them have a different value associated with it. Now, how do you create a priority class? You can create your own priority classes to kind of segregate the different workloads that you deploy on the cluster. So to create a priority class, you can create this object. So you have the API version, kind metadata, and the value. So the API version is scheduling.ks.io/v1. You have the priority class, the kind is the priority class, and then you have a name, which is the name given to the priority class. In this case, is named as high priority. And then you give a value. In this case, it's given a value of 1 billion. So let's say you have, what are the highest priority workloads. So to make sure that they always run, you create a priority class of really high priority and give it the highest priority. And so once you create the priority class, what do? You assign that priority class to your workload. And you do that by specifying a priority class name to the pod definition. So you have your pod definition, and with there you have your containers and all of that information. And along with the container details, you specify the priority class name, and you give the same name of the priority class that you just created. And as simple as that. Now, there are a couple of other kind of properties available when you create the priority class. So what if you don't specify a priority class name for a pod? So you have these different priority classes created, and you're using it for some of your workloads. But let's say for a specific workload, you did not specify the priority class name. Well, in that case, by default, the priority number that those pods get is 0. So that could be anything, right? So you could have priority classes that are lower priority with a negative value, and you could have priority classes that are higher priority, 1,000 with the values of 1,000 or billions. But if you don't specify anything, by default, all the pods that do not have the priority class name specified gets a priority of 0. So, but what if you want to change that from 0 to something else? This is where the global default property of a priority class comes in. So let's say you want to make sure any pod you create where someone does not specify a priority class name gets, let's say, 1,000 or 1,000,000 number in terms of priority. And what you would then do is create a priority class name. You can call it default or something, and then you set the global default property for that priority class to true. And that would mean that any pod that's created that does not have the priority class name set would automatically get the value that's part of this particular priority class that has the global default set to true. Now, then what if you set global default to true to multiple different priority classes? Well, you can't do that, because you can only have one priority class with a global default set to true. All right. So moving on, let's see what happens when you have defined different priority classes and you're deploying different workloads. So let's say you have a cluster with currently there are no workloads, so there's like minimal resource consumed, and you have this jobs workload that comes in, and it has a priority value of 5. And because there are no workloads, there's no competition right now, it's just going to get placed. But actually, wait, it's not created yet. And then we have the critical apps, which is another workload, and that has a priority of 7. So you now have two workloads that have a priority that has two different priorities. So critical apps has 7, jobs is a lower priority workload that has 5. Now, if these workloads were created at the same time, and if the scheduler had to make a decision to place these workloads on the cluster, it would first always prioritize the workload that has the higher priority. So it's just going to place the critical apps first, and then followed by that is going to place the jobs workload, which is the lower priority workload. And let's say by the time these two workloads are placed, the cluster's resources get fully utilized. Now, when something like that happens, and then another workload comes in, which is also a higher priority, but it's a job, but it's of a higher priority. So it's of higher priority than the existing job. So this one has a priority value of 6. Now, what would happen in this case? Well, what happens is determined by another property that's available on priority class called as preemption policy. So preemption policy defines what a workload can do to other workloads in order to get in, right? So by default, the preemption policy is set to preempt lower priority. That means it can kill the lower priority workloads that exist on the cluster. So in this case, because this higher priority job has a, sorry, the value should have been 6, but just an example there. Because let's assume that this higher priority job has a preemption policy set to preempt lower priority. If it comes in, then it's basically going to evict, or it's going to preempt, or it's going to kill that lower priority job, and it's going to use up the resources that were used by that, right? So that's what the preemption policy means. But if you don't want a workload to preempt another workload, then you can just change this preemption policy to never. So that means if that was set to never, then this higher priority job would have stayed in that position and waited until any other lower priority job eventually like automatically ends and resources are freed up. So it would wait till till the cluster naturally has enough resources for it to be placed. But then what is the point of priority class at all? You see, at that stage, if there are multiple workloads that were queued to be placed on the cluster, it will still use the priority value and identify the workload with the highest priority and place that. It's just that it's not going to kill any existing or evict any existing workload to free up resources. It'll wait until it gets enough, until there's enough resources to then be able to have space to be placed on the workload. So that's basically it. Now I'll switch to the labs. So you can also follow along if you'd like. So if you go to the CKA course here, we have the scheduling section. And under the scheduling section, we have if you're already going through the course, or if you've already completed the course, this is a new lecture, so it would have been marked as incomplete. So you'll actually see it here as incomplete, right? So you can just go here and watch the video, and then come here to select the lab. By the way, you'll see it also marked as new. There's a new icon next to each of the lectures that are newly added, and you'll find a bunch of them. So you have a few of these that were added the last time we refreshed the course. And if you go all the way to the bottom, we have these Helm basics as well as customized basics lectures that were added as part of the recent update. So going back here, AWS Lab free access in Playground. So we do have playgrounds where you can get access to AWS, Azure, and cloud. But the cloud accounts, or the cloud accounts are considerably costly than our usual labs, right? Which is why unfortunately we can't make that free. But we are actually exploring right now if there are ways to make at least some of the basic labs or basic cloud accounts free. So that's in the works. But do follow us to know more on that. We will most likely have KodeKloud Engineer updated with some of the cloud labs and make that free too. So I'm gonna try and check the status. By the way, if you guys are not familiar yet, we do have what we call as a job simulation platform called KodeKloud Engineer, and these are basically random tasks, or tasks in a particular order, that are assigned to you every day. So you get like one free task every day. You complete the task, it opens up right in your browser, and you complete the task, and you get some points for it. And using those points, you can open up new tasks. And if you go to curriculum here, you have a bunch of labs, or courses, or tracks, as you can call it here. And one of them is the AWS one. So you'll be given random tasks to complete on an AWS account. You'll get the account ID, password, and everything, and you have to complete those tasks. And you can see all of the tasks that are listed here. So everything as basic as creating key pairs and security groups and volumes and subnets, all the way to working on S3 buckets and VPCs and all of that. And this is just level 1. And I think there are multiple levels to each of them. And similarly, we have the same ones for Azure too. So these are the Azure tasks, and you can just add them to practice, and then they will appear in this section called as the active practice. And then from here on, you can take complete one task at a time. If you need to take a test to see you test your overall level 1 skills on a particular category, you can click on the take a test here. And if you complete that test, then you kind of get a certificate that you can show to prove that like all of these skills that are listed here are those that you have achieved. So I'm still waiting for the lab to load. Just give me 1 second. All right, while we are waiting for the lab to load, maybe one of the things we could do is just quickly go through the prod priority and preemption documentation section on Kubernetes docs site. So if you go to the Kubernetes documentation pages and we just search for priority class, the first thing that comes up is the pod priority and preemption. So this basically talks about everything that we spoke about just now, but this would be good to familiarize with, to know, what commands or codes are there that you can easily copy from. So at the first, in the initial section, we talk about how to use priority and preemption. And then we have priority classes that are defined here. And then, so it's basically just creating a priority class and a definition, and then we'll create a pod with that priority class name. And then we have the priority class definitions here. So this was what we spoke about. So any system critical workloads are created under the priority class system dash. That's the prefix. So that's not allowed for us to create. We're not allowed to create any priority classes with the system dash prefix. And then we have the range that we spoke about. So there's the negative 2 billion or so number to the positive 1 billion number. And then we also spoke about the global default. There's also an optional description field, which I didn't mention, but it's just an optional field that can be used to add an additional description to the priority class. And then we have the priority class definition. So you have the API version, metadata, global default, and description. And we have the preemption policy as well. And then you have the priority class name that's specified here. And there are some additional information that's given here about the limitations of preemption. Sorry, I'm just gonna go and try the lab one more time. And just take a couple of questions here. So we have the question from NG, any plans to add GCP labs in Playground? So I think we already have the GCP labs in our Playground. So if you go to our site under Playgrounds, you should basically see all three, right? So we have all three cloud playgrounds. You have the Google Cloud, Azure, and as well as AWS. And we have a couple of other new AI cloud playgrounds as well that were launched. So you have the AWS AI and Azure AI playgrounds as well. Okay. So can we access all the recording of the seminar? So we have all of the all of the recordings of the previous live sessions, if that is what you're referring to, on our YouTube channel. So if you go to YouTube, if you go to KodeKloud's YouTube channel, and if you go to the live sessions, you'll be able to see all of our previous sessions. So you should be able to see those. Azure DevOps Playground. I think the Azure Playground should have the DevOps services as well. So you should be able to use that. Take another question. So ETA for Golden Kubestronaut courses. So our goal is to get all of the 13 courses out. So we already have 5. We have 2 or 3 that are coming up in the rest of this month. We have, but then there are a few others that are going to take a couple of months more. So our goal is to have it all by Q3, by end of Q3. So yeah, hopefully we will have it by then. Another question is the CKA course now fully updated in KodeKloud? Yes. So I can confirm that is all of the lectures and all of the labs have been fully updated as of last week. And those are the updates that I had shared in one of the earlier slides. Easy 400 by Jeremy, top-notch stuff. Awesome. Thank you so much, Shubham. We're really happy to hear that. And all the best for your certification. Okay, so I guess we have like 7 more minutes. Not sure if I can finish the lab if I started it, but maybe I'll come with something better next time. So yeah, if you have any other questions, feel free to ask here. But I think we can end a bit early today. Well, to those who are on their Kubestronaut journey, all the best, and do keep me posted about your progress. I'm always available on Discord, so do tag me with your questions as well as on LinkedIn. So when you complete a certification, do let me know. But otherwise, I think we'll probably end 7 minutes early today. Well, thank you so much for your time, everybody, and have a wonderful week ahead.